In this video, we will explore the natural language processing technique known as term frequency inverse document frequency, or simply TF-IDF. We will also demonstrate how to implement it through coding. Before watching this video, it might be helpful to watch videos on bag of words and document term matrix to better understand the concepts. In the previous video, we explained the bag of words method as a natural language processing technique. However, TF-IDF is a more advanced method compared to the bag of words. In the bag of words method, the focus is on the frequency of word occurrences without considering the order of words or context. On the other hand, TF-IDF places its emphasis on words that are both frequent within a specific document and rare across the entire documents, providing a more informative representation of the text data. To explain this with an example, let's consider two sentences. The cat is white and the cat is black. When we look at these two sentences, we can see that they both revolve around the color of the cat. The words white and black, which represent the color, appear only once each in these sentences. However, other words like the cat and is appear in both sentences. This suggests that important words are those that frequently appear in a specific document while being less common across the entire document. Term frequency measures the frequency of a term within a sentence. You can think of it as the numerical values you obtained in the document term matrix mentioned in the previous video. To represent term frequency, there are two methods to consider. First, there's the term frequency normalization method, which involves dividing the total frequency of a word appearing in a document by the total number of words in that document. Secondly, there's the Boolean term frequency method, which simply assigns a value of 1 if the word is present in the document, and 0 if it's not. Inverse document frequency, or IDF, quantifies how rare or common the term is across the documents. This helps us understand how important a word is in the context of the entire collection of documents. There are two methods to represent IDF. Firstly, the standard IDF method involves dividing the total number of documents by the number of documents in which the word appears, and then taking the logarithm of that value. If the word appears in many documents, the ratio becomes close to 1, and the logarithm ultimately results in 0. Secondly, the smoothed IDF method, as shown here, involves adding 1 to the calculation. This is done to prevent division by 0 when a word is not found in any document. TF-IDF is the product of the term frequency and the inverse document frequency. When both term frequency and inverse document frequency are high, TF-IDF takes on a high value. This signifies that the word is rare in the entire documents but frequent in a specific document. Therefore, TF-IDF is a measure that indicates the importance of a term within a specific document in the context of the entire documents. In conclusion, higher TF-IDF scores suggest that a term is more important or relevant to the particular document. Now let's calculate the TF-IDF for the two sentences we used in the previous example. The cat is white and the cat is black. Both sentences consist of a total of 4 words, so the term frequency for each word is 1, 4. Out of the two sentences, one contains the words white and black, and the words the, cat, and is are present in both sentences. So the IDF can be calculated as follows. When you multiply the TF and IDF values, you get a TF-IDF of 0.17 for white and black, while the other words have a TF-IDF of 0. As a result, white and black have higher TF-IDF values, indicating that they are more important compared to the other words in the sentences. Let's now calculate the TF-IDF for 4 different sentences. Lee tells Kim, Kim tells Lee eats lunch, and Kim eats dinner. When we calculate Boolean term frequency for these sentences, it means assigning a value of 1 if the word is present in the document, and 0 if it's not. Now, using the smoothed IDF method, let's calculate the IDF values. For the word dinner, it appears once in the 4 sentences, so with the addition of 1, the IDF value is calculated. For the word Lee, it appears 3 times, so the IDF value is calculated as well. When we multiply the TF and IDF values, we find that in the first and second sentences, the word tells has a high TF-IDF, indicating its importance. In the third and fourth sentences, the words lunch and dinner have a high TF-IDF of 1.91, signifying their importance. In conclusion, while the bag of words method only considers the word frequency to represent text in vector form, the TF-IDF method takes into account the importance of each word, allowing us to represent text in vector form with significance considerations. Now let's go ahead and implement the TF-IDF method in code. You can find this Jupyter Notebook file on GitHub, which you can download and run for yourself. First, we'll import the pandas and NumPy libraries. Additionally, we'll import the count vectorizer library to represent text data numerically based on word frequency. We'll store 4 sentences, such as Lee tells Kim, Kim tells Lee, Lee eats lunch, and Kim eats dinner, in the document's variable. Then, using the count vectorizer command, we'll build a vocabulary list, which will include words like dinner, eats, Kim, Lee, lunch, and tells. We can represent the frequency of each word's appearance in vector form for each sentence. For instance, dinner appears once, eats appears twice, Kim appears 3 times, and so on. After that, based on the total number of sentences and the number of sentences where the word appears, we can calculate the IDF by taking the logarithm. When we multiply the TF by IDF, we obtain the TF-IDF values. As explained in the theoretical part, in the first and second sentences, the word tells has a high TF-IDF value, and in the third and fourth sentences, the words lunch and dinner have high TF-IDF values. This demonstrates the importance of these words in their respective sentences. The calculation of TF-IDF may be dependent on the length of the document. To ensure that documents of different lengths are treated equally in terms of importance, you can use the np-linalg.norm code to normalize TF-IDF values. Additionally, I'd like to mention that the process of calculating TF-IDF we've discussed so far can be easily implemented using the TF-IDF vectorizer library. If you store these 4 sentences in the document's variable and execute the TF-IDF vectorizer command, you can obtain a vocabulary list with duplicates removed and their corresponding indices. Finally, you can get the TF-IDF values in matrix form, which will be equivalent to what you calculated earlier using the count vectorizer library.